Hello everyone and welcome to Grade Up. My name is Ashish Sir and today we are here with class 2 of surveying. Okay, so we have finished class 1, that is of linear measurements, and today we'll be taking our discussion forward in surveying and we'll be discussing compass survey. Okay, now from surveying point of view, surveying engineering point of view, this subject in competitive examination holds a slightly lesser weightage. So there are selective topics which are important, like linear measurement. It is one of the most basic and the most frequently asked topic. Compass survey is one of them, and then leveling we'll be doing in the next session. That is also very important. Okay, so we'll wait for more viewers to join. Till then, since we are done with the building material, okay, also we did 4 sessions on that. Okay, and also surveying 1 session we are done with. Okay, so you should attempt the daily quizzes. Okay, also if you are interested, then you can purchase the test series for RRB JE. Okay, so if you have watched these sessions, then well and good. If not, then you can access those on the YouTube channel of our Grade Up. Grade Up Gate. Okay. Yes, a very warm good evening to all of you. Okay. So we'll start our session. Okay. So as it is written on this introductory slide, compass survey. As I've already told, today we'll start with the compass survey. Now, first of all, some of the basic introduction, like what is the compass survey. Okay. Now, compass, as you all know, as the name suggests, it is related to the angles mostly. Okay. Compass survey, in the previous session we have done with linear measurements, that is with related to the lengths, calculating the lengths. Okay, so doing the survey with respect to the lengths. Now here compass survey, it is with respect to measuring angles. Okay, now compass survey is based on traversing. Okay, so from one point you are taking a direction with respect with the help of this compass, then taking length. Okay, then from here taking another station, then from here taking another station and coming back to this station or not coming back. Okay, it depends on the type of survey. Okay, so this area which is to be surveyed, if suppose you are to fix the boundary line, so like this, informed by the taking length and linear measurement, that is known as traversing. Okay, and in compass survey is based on traversing. Okay, one of the student asking, is this class not available on YouTube later on? It will be available to you. Okay, but that will be that after that you will not be able to post your queries. Okay, right now I will be taking live queries, so it will be more beneficial. Okay, now it is recommended when area is large and undulating, since in this case this measuring of lengths becomes difficult. Okay, in large area and undulating area, measuring of length becomes difficult. In that case, compass survey is preferred over taking linear measurements. Okay, now the angles here are taken from a fixed line of reference. Okay, so in order to take any angle, let us suppose if I am saying 60 degree with respect to the horizontal. Okay, so if I only say 60 degree, that really doesn't make any sense. Okay, if I am taking an angle, if I am saying that there is an angle of 60 degree, so we are assuming if it is from the left, if it is from the horizontal direction or if it is from the vertical direction, because interpretations will be different. Okay, so you have to fix a reference for that angle. Okay, so the angles are taken from a fixed line of reference, and in surveying it is known as meridian. Okay, so it is known as meridian. Now there are various kinds of meridian which are defined. Okay, now the first among these is true meridian. Now what is a true meridian? line joining true north, true south and point of reference. Okay, since this is with respect to the objective point of view, that's why I have not written the entire sentence. It will not look good. Okay, so I have only written the key points which are important. Okay, so it is line joining from true north to true south and point of reference, and at a point it is fixed. Okay, so true meridian cannot change. Okay, it is fixed. However, if I come to the magnetic meridian, which is second kind of meridian, then line joining magnetic north, magnetic south and point of reference, that is magnetic meridian, and it is not fixed, it varies with time. Okay, so magnetic meridian changes from place to place. Okay, and it varies with time as well. Okay, now the third kind of meridian is grid meridian. Okay, third is grid meridian. Now for country survey, true meridian through the center place is known as reference. Okay, so if suppose you are taking the survey of entire country, like for India, if you are doing survey, then you have to take a central meridian. True meridian or magnetic meridian may not serve as the purpose, so you have to take some arbitrary meridian. Okay, which is known as the grid meridian. So that is for the country survey. Okay, however, there is one more kind, that is arbitrary meridian. Now this meridian is taken in any convenient or arbitrary direction, usually taken as well-defined permanent point. Okay, like a church spire, permanent point like church spire. Okay, you can take etc. Okay, so church spire can also serve as an arbitrary meridian. Okay, so these are the four kinds: true meridian, magnetic meridian, grid meridian and arbitrary meridian. Okay, now what is a bearing? I have discussed what is a meridian. So what is bearing? Now the direction of the line with respect to fixed meridian. Now you have fixed the reference line. Okay, reference direction you have fixed. So now direction of line with respect to fixed meridian, which you have fixed. It may be true, magnetic, grid or arbitrary meridian. With respect to that, what is the direction of the line? That is known as bearing. Okay, now bearings also are categorized into true bearing and magnetic bearing. Now what is a true bearing? If suppose this is true north. Okay, if suppose this is true north, then horizontal angle measured for any line with respect to true meridian. And if suppose I am saying this is a line A, B. Okay, so true bearing of the line will be this one. Okay, so this will be the true bearing, horizontal angle measured from any line with respect to true meridian. This is the true meridian, that is true north, and AB is the line, and this will be the true bearing. Let us suppose we write it as TB. Okay, true bearing. Okay. Now coming to the magnetic bearing, the other kind of bearing, magnetic bearing. Now in magnetic bearing, if suppose like in previous case I am drawing true north, and let this is magnetic north, there is some error or declination in it. With the true north and magnetic north are not coinciding, there is certain difference in them. So if this is the magnetic north, and similar to the previous case, if this is the line AB, so in this case I have already told you this is true bearing. Okay, while magnetic bearing will be from magnetic north to the line, so this will be the magnetic bearing. Okay, so horizontal angle measured for any line with respect to magnetic meridian, that is known as magnetic bearing. Okay, now designation, there is certain systems by which these bearings can be designated. Okay, now the first among them is whole circle bearing system. Now in this whole circle bearing of a line is horizontal angle between line and north end of the reference meridian. So if suppose this is north, east, west and south. Okay, if suppose this is the line, okay, so this is the bearing. If suppose this is the line, then this is the bearing. If suppose this is the line, now in whole circle bearing, this will be the bearing, and if suppose this is the line, then this will be the bearing. So in whole circle bearing, angle is measured from north end of the reference meridian, that is true north. Okay, so from this you will measure the angle. Okay, no matter in which quadrant the angle is falling, you will measure from true north. Okay, so as you can see, it varies from 0 to 360 degrees. 0 degree when it coincides with north, and if suppose if it is something like this and it coincides here, then it is 360 degree. Okay, WCB is also known as azimuth. Okay, please remember this point from examination point of view. Okay, WCB measured with a prismatic compass. Now later in this presentation, in this lecture, we'll discuss about two types of compasses which are predominantly used. Those are prismatic compass and surveyor compass. Okay, so WCB are measured with a prismatic compass. Okay, for now you just remember this point that WCB is measured with a prismatic compass. It is linked to prismatic compass. Okay. Now that was whole circle WCB, whole circle bearing system. Now the another one is quadrantal bearing system. Now in what happens in quadrantal bearing system, if suppose this is north, this is south, okay, this is east and this is west. Okay. Now quadrantal bearing measure from north point or the south point, whichever is closer. Okay. So representation of quadrantal bearing, how you represent it? First the letter north or south. If we'll take an example, if suppose this is the line, okay, A, this point is, let's suppose this is O and this is A. Okay. So if I talk about OA and this angle is theta 1, let us suppose this angle is theta 1. Okay. So how will you represent the bearing of this line in quadrantal bearing system? First the letter north or south. Now since it is closer to the north, the representation will be north. Now what is the angle? That is then the angle of bearing, that is theta 1, and then lastly the letter east or west. So this line is towards the east, so north, theta 1 east and theta 1 east. So this is the representation. If suppose B, okay, so if I talk about the line OB and let this angle is theta 2. Now this is closer to south point. Okay, so it will be south theta 2 and it is towards east, so E. If I talk about this line OC and let this angle be theta 3. Okay, so it is towards south. Okay, then it is angle is theta 3 and it is towards west. Okay, one more last case. These are some general cases. D point. Okay, so bearing of line OD in quadrantal bearing system will be, it is towards north. Okay, angle is from north, angle is theta 4. So north theta 4 and west. Okay, so this is the representation in 4 quadrants. Angles can be any value. Okay. Okay. So quadrantal bearing measured with a surveyor compass. Earlier WCB is measured with prismatic compass. Okay, and surveyor compass, quadrantal bearing is measured it with surveyor compass. So remember these 2 points. Objective question can be framed with respect to this point also. Okay, so do not get confused. Now conversion of WCB to quadrantal bearing. Okay, now suppose you are provided with whole circle bearing and you want to convert it into quadrantal bearing, or the angle is provided in quadrantal bearing and you have to convert it into WCB. So in that case this table will be helpful to you. Okay, already I have given you this representation. Okay, so already I have given you this representation. Okay, this is north, south, east, west. Okay, so WCB between theta to 90. So theta to 90 is this quadrant. Okay, we are talking about this quadrant. So the reduced bearing for this will be equal to WCB, because for any angle with respect to this, it will be equal to the theta will be equal to theta. Okay, if suppose this is the bearing, so if it is theta 1, okay, quadrant is northeast and reduced bearing will be WCB. If suppose with respect to this, the angle is theta 2, 90 to 180. Now in that case, the reduced bearing from this north will be 180 minus theta 2. Okay, so 180 minus WCB. Okay, So 180 minus, sorry, this is WCB theta 2. Okay. So it will be the reduced bearing will be 180 minus theta 2. So this angle you will get 180 minus WCB, and quadrant is southeast. Now similarly this, suppose this is the, this is getting messy, so I'll draw a new one, east, west. Okay. So for 180 to 270, that is southwest quadrant. Okay. If suppose this is the theta 3, that is the your whole WCB. Okay. So in order to get the reduced bearing, this is the reduced bearing you will get. Okay. So that is theta 3 minus 180, that is WCB minus 180. Okay. Then 270 to 360. Okay. So this angle. So if this angle is theta 4. Okay. So for this, the reduced bearing will be this one, that is 360 minus WCB, and quadrant will be northwest. Okay. So this is how you will convert these bearings into WCB to quadrantal bearing, or quadrantal bearing to WCB. Okay. Now in bearing itself there comes two terms, fore bearing and back bearing. So what is a fore bearing and what is a back bearing? Let me explain it here. So if suppose this is, I have this line, okay, this line is A, B, okay. So bearing in the direction of progress of survey. So we are progressing from A to B. So if I say talk about this bearing, so this will be the fore bearing. Bearing in opposite direction is back bearing. So from north to the line, this is the whole circle bearing, and this is the back bearing of this line. Okay. So fore bearing and this is back bearing. Okay. Now back bearing is equals to fore bearing plus minus 180 degree. Okay. So here you can see this back bearing is equals to fore bearing plus minus 180 degree. Okay. So this relation you should remember. Okay. The angle should not be negative, so that's why plus minus is there. Depending on the quadrants which it fall in, it will slightly change the sign. Okay. Now what is declination? Now earlier I had drawn a diagram. Okay. It was something like this. This is the true north and this is the magnetic north. Similarly, the other case can be true north and that is magnetic north. Okay. So here, what is declination? Now, magnetic declination, it is the horizontal angle between true meridian and magnetic meridian. Okay. So this angle, this is the declination. Okay. So this is referred to as declination. Okay. So it can be eastern or western declination. Now since you can see here, this is western declination. Okay. While this one is eastern declination. Okay. So these are two types of declination. Now there are two types of lines which are concerned with declination. One is isogonic and another one is agonic. These two are very important from the examination point of view. Okay. So isogonic is line with same declination. If two lines are having same degree of declination, then those are isogonic to each other. While if lines with zero declination, if the true north and magnetic north of a line coincides, then those lines are known as agonic lines. Okay. So remember these two these two lines. Okay. Also, with respect to dip, we will discuss later in the presentation in today's lecture itself. Two lines are also considered isoclinic and aclinic. Okay. So these four lines are to be remembered by heart and without any confusion. Okay. Now, variation of declination. Now the declination varies from time to time. Okay. It can vary from time to time and place to place. Now first is, as I have written, secular variation, then there is annual variation, diurnal variation and irregular variation. Now the first one is secular variation. Now secular variation, it occurs over long period of time. Okay, it is approximately, it follows approx sine curve. Okay, also for certain period of time it will this shift will be in one direction, and then from that period to some other to the period in the future, that will be in the opposite direction. So like that way it follows a sine curve. Okay, so this is secular variation. Then there is annual variation. Annual variation, as the name suggests, it is yearly variation. Okay, this is yearly variation, and it occurs due to rotation of earth around sun. Okay, now this is the annual variation. Then there is diurnal variation. Diurnal is daily variation, that is 24 hours. Okay, now this is due to rotation of earth about its own. Okay, diurnal is not visible to you people. Okay, I'll write it again. So diurnal is daily variation. Okay, and also it occurs due to rotation of earth about its own axis. Okay, also I will be writing it here, the annual variation. I think it is also not visible. Okay, yes, I am taking care of it. Okay, so it is yearly variation, and it is yes, Akhil, I am taking care of it. Do not worry. Concentrate on the studies. Okay, rotation of earth around sun. Okay. Okay. So there is secular variation, then there is annual variation, diurnal variation, and one more is there, that is irregular. Okay. So I will just write it in the next slide. That is no. Irregular variation is due to the magnetic disturbances. Okay, so magnetic disturbances in Earth's magnetic field will lead to the irregular variation of declination. Also, earthquakes are also responsible, partly responsible. Earthquakes and volcanic eruptions. Okay, so these will also affect the magnetic declination. Okay, so these are the 4 types of variations which occur of declination. Okay, so now another topic is local attraction. Now what is local attraction? It is attraction of the magnetic needle to the local magnetic field. If suppose the magnetic needle is close to some magnetic material, okay, it can be any machine, okay, or natural source, okay, so that leads to the attraction of the magnetic needle, and it will lead to error. That is known as local attraction. Okay, so if the difference between fore bearing and back bearing is 180 degree, then both the end stations, if suppose fore bearing, this is a check, okay, it is like a check on local attraction. So if the difference between fore bearing and back bearing is 180 degree, then both end stations are free from local attraction, but there is a condition here. The compass should be free from instrumental errors. There should not be any instrumental errors in the compass. Okay, only then we can assume that the end stations are free from local attraction. Okay, now the case arises if difference of fore bearing and back bearing is not equal to 180 degree, then what? Then this discrepancy or error, okay, introduced may be of first. It may be error in observation of either fore bearing or back bearing or both. Okay, so there may be error in taking these readings, angles, fore bearing, back bearing, or even both. Okay, also it may be presence of local attraction at either one or both stations. Okay, so this local attraction will affect our compass survey. Okay, so like this, if difference is 180 degree, then we consider that both ends are free from local attraction and compass is free from instrumental errors, provided this is the condition here. But if the difference is not equal to 180 degree, then discrepancy may be due to first error in taking observations or presence of local attraction. Okay, so this was about the local attraction. Couple of things will get clear when we will be taking a numerical. Okay, so now we move the last topic of compass survey, that is, sorry, not last. Okay, so dip. Now what is dip? It is the vertical angle made by lines of magnetic forces with earth surface. Now declination were horizontal angle, while dip is vertical angle. Okay, just remember in this way. Okay, so it is the vertical angle made by lines of magnetic force with earth's surface. It varies from 0 to 90 degree, and like I have told already, isoclinic lines and aclinic lines. Okay, now what is isoclinic lines? It is lines with same dip. Now in order to remember, you can also remember like this, dip, the middle word is I, okay, and isoclinic, the first word is I. Okay, so dip, declination. So dip is concerned with isoclinic and aclinic. If clinic you remember, then aclinic you can remember. Okay, and it is isogonic. There are slightly more I's in here, and agonic. Okay, so sound you can remember by the same sound. Isoclinic, a lot of I's, and dip is I. Okay, declination, isogonic, agonic. Okay, so isoclinic is line with same dip, and aclinic is line with zero dip. Now, like I have told you, we'll take a comparison of prismatic and surveyor compass. Okay, so prismatic compass, graduation circle is fixed to broad needle, hence it will not rotate with line of sight. Okay, now quickly let's go to this diagram. This is prismatic compass. So this graduated, this is the so this is the graduated circle. It is linked to this needle, so it will not rotate with the box. Okay, so in prismatic compass, graduated circle is fixed to broad needle, hence it will not rotate with line of sight. While in surveyor compass, graduated circle is fixed to box, hence it will rotate with line of sight. Okay, so here you can see the difference. Here this is the okay, so this is the graduated scale. It is attached to the box, so it will rotate to the, it will Okay, so it will rotate with line of sight. Okay, now in prismatic compass, as the name suggests, prism is used for viewing. Okay, while there is in survey compass there is only slit instead of prism. Okay, so you have to take the reading from top. Okay, so here due to the availability of prism, sighting and reading can be done simultaneously. Okay, while in survey compass, sighting and reading cannot be done simultaneously, because in order to take the reading you have to watch it from the top. Okay, you have to take the reading from the top. Okay, so prismatic has an advantage, sighting and reading can be done simultaneously. Now here prismatic compass, magnetic needle do not act as index, while in survey compass it also acts as index. As you are seeing reading from the top, so that will act as an index. Okay, while in this prismatic compass, since you are viewing the reading from prism, so magnetic needle do not has to serve the purpose of being index. Okay, now prismatic compass graduations are in WCB, while in survey compass graduations are in quadrantal bearing. Also, reading is taken through a prism, reading is taken directly from top glass. Okay, also there is one more thing available in survey compass, jewel bearing. Okay, so at times in examination I have seen frequently this question coming of jewel bearing, so it is concerned with the survey compass. Just remember this much point. Okay, so this was a comparison. These are the basic diagrams. I have put it in one frame so that you understand it better. You can see this is the prism. Okay, so this is the prism. Okay, this is the object vane here. Okay, this is the graduated ring. It is attached to the needle and not the box. While here you can see this is the ring and it is attached to the box. Okay, also there is no prism here. There is object vane and there is eye vane here. Also this is the jewel bearing I am talking about at the middle. Okay, it is supported on a pivot. Okay, so these were the main differences about prismatic compass. See, objective questions will definitely come from this topic, so I would recommend you to study it in detail. Okay, so now coming to the questions. Now the first question, if the questions asked from this topic are pretty simple, so you should not do it incorrectly. Okay, just focus your attention and try to solve them. They are very easy, and just take care of the angles, particularly in this topic. Okay, so if the bearing of AB is north 40 degree west and bearing of BC is south 70 degree east, then the value of angle ABC is. So with the help of bearings you have to calculate the included angle here. Okay, so if I draw it here, so this is, let us suppose this is station A. From here 40 degree northwest. Okay, so slightly till, let us suppose at this point. This is B. Now the bearing is 40 degree here. Now from B to C is south 70 degree east. Okay, so B is south 70 degree east. Okay, so here it will be like this. Okay, and this angle will be 70 degree. Okay, this angle will be 70 degree. So you have to calculate the included angle, angle ABC. So angle ABC will be equal to this bearing of BC. Since this is 40 degree, this will be 40 degree. So angle this will be bearing of BC minus bearing of AB. Okay, so that is equals to 70 degree minus 40 degree, 30 degree. Okay, so A is the correct option to this question. Okay, I hope you have got it correctly. Now the second question. Now the dip of the compass needle, option A, is constant, varies from place to place and is 0 at equator and maximum at poles. C is 0 at equator and poles, none of these. Okay, so for this, let us suppose this is our Earth. Okay, and these are the magnetic lines which are, this is the magnetic field generally. Okay, so if suppose this is the equator, and this is our pole. Okay, this is north pole and this is south pole. Okay, so at this direction it will be, there is horizontal magnetic needle. Okay, so at poles the magnetic fields are perpendicular to the earth surface, while at this equator the magnetic fields are parallel to the earth surface. So that's why at equator the magnetic needle will be horizontal. Okay, it will be parallel to the, in the direction of magnetic field, and that is parallel to the earth surface, while at poles it will be like this, that is vertical magnetic needle. Okay, so it varies from place to place. Yes, it will vary as we go from equator to pole and pole to equator, and is 0 at equator. Okay, and is maximum at poles, 0 and maximum, that is 90 degree. So B is the correct option to this question. Okay, now question number 3. If the fore bearing of the line is observed to be this much, then the back bearing of line AB should be. Okay, so fore bearing, now back bearing is fore bearing plus minus 180 degree. So if fore bearing is less than equal to 180 degree, then in that case back bearing is equals to fore bearing plus 180 degree, while if fore bearing is greater than 180 degree, then back bearing is fore bearing minus 180 degree. Okay, so this case lies in this one. This is first, this is second. So ours is the first case. So back bearing will be fore bearing plus 180 degree. Okay, so back bearing will be 12 degree 24 minutes plus 180 degree, and if you add these two, 192 degree 24 minutes, that is option B. Okay, so B is our correct answer to this question. Now question number 4. Now the reduced bearing of the line is north 87 degree west, its whole circle bearing. Okay, I have explained it very well. Okay, so this is north, south, this is east, this is west. Now north west, okay, 87 degree. So this will be almost like this, and this will be the angle 87 degree. So this line is north 87 degree west. Now you have to find the whole circle bearing. Now whole circle bearing will be this one. Okay, so for northwest quadrant, the whole circle bearing is equals to quadrantal bearing, that is reduced bearing, plus, sorry, it will be 360 degree minus reduced bearing. Okay, so this whole is 360 minus 87 degree, that will give the whole circle bearing. So 360 degree minus 87 degree. So WCB is 273 degrees. 273 degrees. Okay. This question is quite popular in competitive examinations. Okay. So I would recommend you to practice it. Okay. Now, coming to the next question. The magnetic bearing of the line is south 45 degree east and the declination is 5 degree west. The true bearing of the line AB is. Okay. Now this question is also very popular in competitive examinations. Okay. So practice 2 and 3. 1 I am practice making you practice it here. 2 things questions you can solve it on your own. Okay. So in 5th question, first of all, in these types of question, you have to draw true north. Okay, this will be true south. Okay, now the declination, then you will have to draw the magnetic north. Now since declination is 5 degree west, so the magnetic, this will be magnetic north, that is 5 degree west. So here this will be magnetic south, this will be true south. Now the bearing is south 45 degree east, that is magnetic bearing. So from here you have to construct a line at an angle of 45 degrees. Okay, so this will be east west. Okay, so the magnetic this is the line AB, that is for south 45 degree east magnetic bearing. Now you have to find the true bearing of the line, this line. So this angle, you know, from vertically opposite, this is 5 degrees. Now true south is this. So the true bearing will be this one. So true bearing will be equal to south 45 plus 5, that is 50 degree east. Okay, so C is the correct option to this answer, this question. Okay, please practice 2-3 more questions of this type, magnetic bearing given and declination, or in some other case true bearing will be provided to and declination will be provided, and you have to find the magnetic bearing. Okay, so practice such questions, right? Now coming to the last question of this session, as I have told, of the local attraction. Now here the following bearings are observed by traversing with a compass. This is a survey, okay, compass survey. Now difference of so in order to check for local attraction, you have to check which stations are affected by local attraction, AB, BC, CD or AD. Okay, so you have to find the difference. Okay, so if you find the difference of fore bearing and back bearing of line AB, that is exactly equal to 180 degree. For BC it is 177 degree and 45 minutes. For CD it is 175 degree and 15 minutes, and for DA is 177 degree. So except for line AB, none of the lines have difference exactly equal to this one. So let us suppose the compass is performing, there is no instrumental error in compass. So it says that A and B will be free from local attraction. So since these for line AB we are getting the difference of back bearing and fore bearing exactly equal to 180 degree. So that means both the stations are free from local attraction, since we have considered that the survey was correct and there was no any instrumental error. Okay. Now other than these C and D, all the other angles are not equal to 180 degree. Okay. So we can deduce that C and D are affected by local attraction. See, more complicated problems can be framed in with respect to this topic, but since this is for RRB JE and SSC JE level of questions, so they won't be asking much harder questions. Okay, so you have to practice the easy ones and make sure that you do not solve them incorrectly. Okay, so from JE point of view, these type of questions will be beneficial. Okay, so C and D, you may find them easy, but in the while attempting the examination, the mistakes can be there. Okay, so take these differences correctly. Okay, do not do calculation errors. Okay, other than that, calculating included angles, and that is part of a conventional question. Okay, from objective point of view, that is not important, so I am not discussing that part. Okay, so with this we have come to the end of this session. I hope this was equally helpful to you. If you have watched it already, then well and good. If not, then please go to the YouTube channel of Grade Upgrade. Also watch the building material series which we did earlier. And in the next lecture, we will be discussing leveling, surveying subject. That will be the last topic for surveying. Then we'll move to the soil mechanics. Okay. So thank you for watching this video and have a great day ahead.